Okay, Bismillahirrahmanirrahim. Hai, Assalamualaikum. My name is Muhammad Azri bin Mat Azmi and my matrix number is 01DKA21F1083. Okay, today me and my group present about firework 2 about total station. Okay, first of all, I want to introduce my group member. Okay, first Muhammad Azmi bin Musa. Second, Syaban Rao anak lelaki Bisbarau. And third, Masyarah Asfar bin Nursaini. Okay, and my name is Muhammad Azri bin Mat Azmi. Okay, next I go to my topic is introduction. Okay, theory of traverse survey. Okay, theodolite measurement is ordered to determine position of distance and direction of bearing. The direction of survey line is generally expressed as an angle measured from a reference meridian, generally not commencing from 0 degrees and increasing clockwise to 390 degrees. Okay, traverse is a method in the field of surveying to establish control networks. It is also used in geodesy. Okay, traverse network involves placing survey station along a line or path of traverse and then using the previously surveyed points as a base for observing the next point. In survey, traverse is defined as the operation of measuring the length and direction of a series of straight lines connecting a series of points on the earth. Each of the straight line is called a traverse line and each point is called a traverse station. Traverse stations are commonly marked with wooden peg, stake, nail or iron pipe. Okay. Traverse lines are measured using total station. Traversing need to start from reference datum, coordinate, bearing and distance are known. Okay. Each traverse station, a horizontal angle is measured and used to determine the bearing of the next traverse line. These measurements are used to compute the relative horizontal position of each unknown traverse station. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Azmil bin Musa. Metric number 01DKA21F1091. Okay, next I will continue with my part, which is use of equipment in survey work. Firstly, we have a total section, an optical surveillance instrument that use electronics to calculate angles and distance. It combines the functions of a theodolite with that of a transit level and electronic distance meter. Secondly, we have a tripod. Tripod providing the foundation for laser levels and other leveling instruments. Other than that, it is used for supporting and keeping survey equipment stable, particularly while working on uneven terrain. Thirdly is prims. It used to measure the change in position of a target that is assumed to be moving. Next is prismatic compass. A surveyor hand compass provided with a triangular glass prints so adjusted that the compass can be read while taking a side. It used to measure the angles known as bearing. Plane table surveying, a graphical method of survey in which the field, observation and plotting are done simultaneously. It is simple and cheaper than theodolite survey, but it is mostly suitable for small-scale survey. It provides a solid and level surface on which to make field drawings, charts and maps. The second last is picket. It used to marking the total section to ensure that the laser on the total section is directly above the point marked on the picket before the measurement work is cut. And lastly is hammer. Hammer serves as a tool for knocking and immersing the picket into the ground before the measurement work shear start. That's all from me. Thank you.
Good morning, Miss. I'm Shoban Rao, and today I'm gonna explain about the data collection. Let's go. Okay, over here you can see I construct a diagram using the table given in the report, and from there I find out this diagram, and which is in pentagon shape. I created using a pentagon shape because there are 5 sections. And then down here there's a table which I took out, and I list out the bearing and distance. From line 1 to 2 I got bearing 125 degrees 45 minutes 20 seconds, and the distance is 78.408 meter. From 2 to 3 bearing is 199 degrees 18 minutes 40 seconds. The distance is 83.212 meter. Line 3 to 4 277 degrees 6 minutes 0 seconds. Distance 52.810 meter. 45 333 degrees 17 minutes 0 seconds 94.645 meter. In the line 5 to 1 60 degrees 29 minutes 50 seconds 67.622 meter, and total for the distance I got is 376.697. Okay, in this latitude and departure I use the formula. Okay, for latitude I use the formula which is distance cos bearing, and for departure distance sine bearing. Okay, over here I mentioned that n is plus and s is minus. Okay, you might be thinking what is plus and minus over here. Okay, here not if in the formula distance cos bearing, if the answer is in positive it must be in n category, if which is not. If it's negative it must be in south category. So over here you can see I have calculated and put it in the respective places, which is bearing and distance is in bearing for the first one is in south, the second one is also in south, and the third, fourth, fifth is in north. Same goes to departure, which is east and west. East is positive, west is negative. The formula of distance sine bearing. And over here east, if I got for the first one and the fifth one, 1 2 3 4 5, yeah, fifth one, and the second, third, fourth I got west. Okay, after calculating everything, and the total for north I got 124.37, and for south I got 124.346, and I deduct both of them, I got 0.024, which is we're going to use that for the next calculation. And for the departure east I got the total for east I got 122.483, and for west the total I got 122.473, and the difference I got is 0.01. Okay, this is where we're going to use the value of 0.024 and 0.01, and it is for linear disclosure and relative precision. For linear disclosure, what we need to do is the value of 0.024 need to square plus with 0.1 square, and you square root that, and I got the answer which is 0.026. And for the relative precision, what I did was 0.024 divided with 376.697. 376.697 is the total of direct distance, and I got 5.575, and the actual answer is 1/5.575 for relative precision. And the final part is correction, and I did all of this. You can see here from the line, distance, departure, latitude, and the correction for departure and latitude, and I balanced the departure and latitude. Alright, that's all for today, and thank you very much.
Assalamualaikum. My name is Om Syawal Zafar bin Shaini, and my metric number is 01DKA21F1075. Now I will talk about the conclusion. In conclusion, we are able to describe the various components of the diode. After then the practical, we understand how to describe close traverse survey. Example of tool station is tripod, prism, and prismatic. Besides that, we know how to determine the final bearing by using suitable method. Then, we have a knowledge of all the equipment required to carry out, and then we know the advantage of bearing and their use in various survey work. We are to be familiar with the check and error in a closed traverse and solve them. Furthermore, we often develop skill in using total station, thus could be explored more functions that exist on the instrument. Finally, we get to know or understand collimation error and how it can be corrected. That's all from me and my team. Thank you.